In this short video, I'll describe a recent study which reveals opposite perceptual characteristics in dyslexia and in autism. Contrary to our intuitions, perception is a mixture of both the current sensation and our previous experiences. Therefore, as experienced perceivers, we only need partial information to infer external objects. We learn to do this over time by experiencing many examples. We illustrate this with an example based on an experiment by Johansson. Looking at this unfamiliar stimulus, we see a set of moving dots. However, when rotated by 180 degrees to the direction we saw throughout our life, it elicits a rich percept of a moving person. The perceptual experience also allows us to update our expectations according to recent information. For example, this stimulus is not typical to any of the stimuli we have previously seen. But with additional information, we can quickly update our expectations for this type of object and perceive it clearly. Same with speech. What does the person say? Atypical stimuli, in this case impoverished speech, are difficult to decipher. But informative input quickly updates our predictions and clarifies our perception. Now let's hear the original recording.
The man's painting a sign.
If you are an experienced English speaker, your perception has quickly adapted. In our lab, we quantify the effect of both recent history, whose impact is crucial for fast updating when stimuli change, and long-term history, whose impact is crucial in forming reliable and rich percepts in stable environments. Let's illustrate the effect of recent history in pitch discrimination. In each step, we present two consecutive tones. Listen carefully. Which one has a higher pitch? These tones are ambiguous. Some hear them as going up, some as going down. Now let's play the same tones again, but this time we add preceding context tones. In this context, for most people the same tones are now perceived as going down in pitch. Now let's hear it in a different context. In this context, for most people the same tones are now perceived as going up in pitch. Previous works showed that although dyslexia and autism are very different developmental disorders, perception in both reflects underuse of previous information. We now used pitch discrimination to study the effect of both recent and long-term history in these two populations. In dyslexia, we found that recent experiences are influential, but the accumulative effect of examples over time is smaller. As a result, representations of patterns like words and sentences, even after massive exposures, are like after fewer ones. In autism, on the other hand, we show that examples are learned accurately over time, but recent experiences are less influential. This slows the rate of updating responses to new and unexpected information, and consequently makes social interactions and online motor responses like driving difficult. By contrast, things that are stable over time can be mastered with accumulative experience. In the future, we shall adapt the rate of change of external stimuli to individuals' natural pace, and test whether it facilitates learning.